Amazon Web Services, or AWS, is the world's largest cloud service provider with over 175 services. Not just that, it is also the most broadly adopted cloud platform with a wide range of customers that include the fastest growing startups, largest enterprises, and leading government agencies. From infrastructure technologies like compute, storage, and databases to emerging technologies such as machine learning, artificial intelligence, data lakes, and analytics, and Internet of Things. AWS provides all the necessary services that will allow you to build nearly anything you can imagine. So hey guys, welcome to a whole new session from Edureka. To begin with, we shall discuss a little about what exactly is AWS and what is an API. Following that, we shall understand what is the AWS API Gateway, who uses it, and its features. Then, we shall take a look at some of the important terms and concepts, followed by the pricing in AWS API Gateway. Once we're done with that, I'll be showing you a hands-on demonstration of building an AWS API Gateway by creating a REST API using Lambda services, as well as creating a REST API with the mock integration. So coming back towards the session, what is AWS? AWS, or Amazon Web Services, is a cloud service from Amazon which provides services in the form of building blocks. These building blocks can be used to create and deploy any type of application in the cloud. These services or building blocks are designed to work with each other and result in applications that are sophisticated and highly scalable. Amazon Web Services houses a collection of cloud computing services that have opened up hot career perspectives in the world of cloud computing. There are 5 different certifications, and each of them open floodgates of enhanced career opportunities. So now that you have a brief idea of what is AWS, let's move on and take a look at what is an API. API is basically the acronym for Application Programming Interface, which is a software intermediary that allows 2 applications to talk to each other. Suppose you're searching for a hotel room through an online travel booking site. Using the site's online form, you will fill the necessary information like the city you want to stay in, check-in and check-out dates, number of guests, and the number of rooms. Then you click Search. But what exactly is going on between entering your information to receiving your hotel choices? Yes, that's API. The site aggregates information from many different hotels, and when you click Search, the site then interacts with the hotel's API, which delivers results for available rooms that meet your criteria. And all this happens in seconds because of an API, which acts like a messenger that runs back and forth between applications, databases, and devices. So what exactly is the AWS API Gateway? The AWS API Gateway is basically a service provided by Amazon that is used to create, publish, maintain, monitor, and secure various APIs such as REST API, HTTP, and WebSocket at any scale. As an API developer, you can create APIs that can access either Amazon Web Services or any other web services along with the data stored in the AWS cloud. As an AWS Gateway API developer, you can create APIs for use in your own client applications as well as make your APIs available to third-party app developers. The API Gateway creates RESTful APIs. The term REST basically stands for Representational State Transfer. It is an architectural style that defines a set of rules in order to create web services. In a client-server communication, REST suggests to create an object of the data requested by the client and send the values of the object in response to the user. For example, if the user is requesting a movie in Bangalore at a certain place and time, then you can create an object on the server side. So over here, you have an object and you are sending the state of an object. This is why REST is known as Representational State Transfer. The architectural style of REST helps in leveraging the lesser use of bandwidth to make an application more suitable for the Internet. It is often regarded as the language of Internet and is completely based on the resources. The features of API Gateway. Amazon API Gateway offers features such as support for stateful or WebSocket and stateless or HTTP and REST APIs. It is powerful, provides flexible authentication mechanisms such as AWS Identity and access management policies, Lambda authorizer functions, and Amazon Cognitive user polls. You can also make use of the developer portal for publishing your APIs. It also provides canary release deployments for safely rolling out changes. It provides CloudWatch access logging and execution logging, including the ability to set alarms. You will also be able to use the AWS CloudFormation templates to enable API creation. It also provides support for custom domain names and integration with AWS WAF for protecting your APIs against common web exploits. Also, integration with AWS X-Ray for understanding and triaging performance latencies is available. So those were some of the features of the AWS API Gateway. Talking about the benefits of using the AWS API Gateway. Now, there are a number of benefits of using the AWS API Gateway. First is that it supports efficient API development. You will be able to run multiple versions of the same API simultaneously when you make use of the API Gateway, which allows you to quickly iterate, test, and release new versions. Also, you will have to pay for calls made to your APIs and data transfer out, and there are no minimum fees or upfront commitments. Performance at any scale. You can provide end users with the lowest possible latency for API requests and responses by taking advantage of the global network of edge locations using Amazon CloudFront. Throttle and traffic authorize API calls to ensure that backend operations withstand traffic spikes and backend systems are not unnecessarily called. The Amazon API Gateway provides a tiered pricing model for API requests. With an API request price as low as $0.9 per million requests at the highest tier, you can decrease your costs as your API usage increases per region across your AWS accounts. Easy monitoring. Performance metrics and the information can be monitored on API calls, data latency, and error rates from the API Gateway dashboard, which allows you to visually monitor calls to your services using Amazon CloudWatch. Flexible security controls. You will be able to authorize access to your APIs with AWS Identity and Access Management, or the IAM, and Amazon Cognito. If you use OAuth tokens, API Gateway offers native OIDC and OAuth2 support. To support custom authorization requirements, you can execute a Lambda authorizer for AWS Lambda. RESTful API options. Create RESTful APIs using HTTP APIs or REST APIs. HTTP APIs are the best way to build APIs for a majority of use cases. They are up to 71% cheaper than REST APIs. If your use case requires API proxy functionality and management features in a single solution, you can use REST APIs. So who makes use of the API Gateway? The API Gateway is basically used by two types of developers, that is, the API developers and the app developers. An API developer is basically someone who creates and deploys APIs to enable the required functionality of an API Gateway. To make use of AWS API Gateway, you must be an IAM user in the AWS account that owns the API. On the other hand, an app developer builds a functioning application to call AWS services by invoking a WebSocket or REST API created by an API developer in the AWS API Gateway. This way, the app developer becomes the customer of the API developer. Therefore, the app developer does not require to have an AWS account. However, the API that is created should either not require the IAM permissions, or it should support authorization of users through third-party federated identity providers that are supported by Amazon Cognito User Pool Identity Federation. Such identity providers include Amazon, Amazon Cognito User Pools, Facebook, and Google. API Gateway REST API. So if you remember, we've spoken about REST API, WebSocket API, and HTTP API. Now let me just brief you about each of these. API Gateway REST API. It is basically a collection of HTTP resources and methods that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. You can deploy this collection in one or more stages. Typically, API resources are organized in a resource tree according to the application logic. Each API resource can expose one or more API methods to have unique HTTP verbs supported by the API Gateway. Using AWS API Gateway, you can create RESTful APIs that are HTTP-based and can enable stateless client-server communications, and also implement standard HTTP methods such as GET, PUSH, POST, PATCH, and DELETE. The AWS API Gateway WebSocket API. It is basically a collection of WebSocket routes and route keys that are integrated with backend HTTP endpoints, Lambda functions, or other AWS services. Just as REST API, you can deploy the collection of WebSocket APIs in one or more stages. API methods are invoked through front-end WebSocket connections that you can associate with a registered custom domain name. The AWS API Gateway will create WebSocket APIs that adhere to the WebSocket protocol, which enables stateful, full duplex communication between the client and the server. Also, you can route incoming messages based on the message content. API Gateway HTTP API. It is nothing but a collection of routes and methods that are integrated with backend HTTP endpoints or Lambda functions. Just as the previous two, you can deploy this collection in one or more stages. Also, each route can expose one or more API methods that have unique HTTP verbs supported by the API Gateway. Now that you have a brief idea about the three types of APIs available, let's take a look at some of the important terms and concepts that you should be aware of when you're working with APIs. First up is API development. It is nothing but a point-in-time snapshot of your API Gateway API. To be available for the client's use, the deployment must be associated with one or more API stages. API developer. This is nothing but your AWS account that owns an API Gateway deployment. For example, a service provider that also supports programmatic access. API endpoint. An API endpoint is a host name for an API in API Gateway that is deployed to a specific region. An API key. An API key is basically an alphanumeric string that API Gateway uses to identify an app developer who uses your REST API or the WebSocket API. API Gateway can generate API keys on your behalf, or you can import them from a CSV file. These API keys can be used along with Lambda authorizers or usage plans to control access of your APIs. API stage. An API stage is a logical reference to a lifecycle state of your API. These API stages are identified by an API ID and the stage name. A callback URL. When a new client is connected through a WebSocket connection, you can call an integration in API Gateway to store the client's callback URL. You can then use that callback URL to send messages to the client from the backend system. Developer portal. An application that allows your customers to register, discover, and subscribe to your API's products, manage their API keys, and view usage metrics of your APIs. Edge-optimized API endpoint. It is the default host name of an API that is deployed to the specified region while using a CloudFront distribution to facilitate client access typically from across the AWS regions. API requests are routed to the nearest CloudFront point of presence or POP, which typically improves connection time for geographically diverse clients. Integration requests. It is the internal interface of a WebSocket API route or REST API method in an API gateway. In API gateway, in which you map the body of a route request or the parameters and the body of a method request to the formats that are required by the backend. Integration response. The internal interface of a WebSocket API route or REST API method in API gateway in which you map the status codes, headers, and payload that are received from the backend to the response format that is returned to a client app. A mapping template. It is a script in Velocity Template Language or VTL that transforms a request body from the front-end data format to the backend data format, or that transforms a response body from the backend data format to the front-end data format. Mapping templates can be specified in the integration request or in the integration response. They can reference data made available at runtime as context and stage variables. The mapping can be as simple as an identity transform that passes the headers or the body through the integration as is from the client to the backend for a request. The same is true for a response in which the payload is passed from the backend to the client. Method request. It is the public interface of an API method in API Gateway that defines the parameters and the body that an app developer must send in requests to access the backend through the API. Method response. It is the public interface of a REST API that defines the status codes, headers, and body models that an app developer should expect in response from the API. Mock integration. In a mock integration, API responses are generated from API Gateway directly without the need for an integration backend. As an API developer, you decide how API Gateway responds to a mock integration request. For this, you configure the methods integration request and integration response to associate a response with a given status code. Model. A model is basically a data schema specifying the data structure of a request or a response payload. A model is required for generating a strongly typed SDK of an API. It is also used to validate payloads. A model is convenient for generating a simple mapping template to initiate creation of a production mapping template. Although useful, a model is not required for creating a mapping template. So those were some of the important terms that you should be knowing in order to move ahead with the session. Don't worry if you haven't understood it completely. We'll be elaborating more over this when we move on to the hands-on session. Before we move on to the hands-on session, let's discuss the pricing of the AWS API Gateway. With the AWS API Gateway, you only pay when your APIs are in use. There are no minimum fees or upfront commitments. For HTTP APIs and REST APIs, you pay only for the API calls you receive and the amount of data transferred out. There are no data transfer out charges for private APIs. However, AWS private link charges apply when you're using private APIs in the API Gateway. API Gateway also provides optional data caching charged at an hourly rate that varies based on the cache size you select. For WebSocket APIs, you only pay when your APIs are in use based on the number of messages sent and received and the connection minutes. The API Gateway free tier includes 1 million HTTP API calls, 1 million REST API calls, 1 million messages, and 750,000 connection minutes per month for up to 12 months. Post-free tier services, you will be charged based on the region, the type of API service that you use, and the number of requests. To know more in detail about the pricing, you can check out the official AWS API Gateway pricing page. Here, you will find all the necessary details based on the region of your choice. Now let's move on towards the most interesting part of the session, which is creating APIs using the AWS API Gateway. Prerequisites. Before using the Amazon API Gateway for the first time, you must have an AWS account. Therefore, you will have to sign up for an AWS account. And once your account has been created, you should also create an AWS Identity and Access Management, that is an IAM user with administrator permissions. To know more about how to create an AWS account, make sure to check out AWS Crash Course video from Edureka. Creating a REST API using Lambda. Now before doing that, I'll just brief you about what is AWS Lambda. AWS Lambda is basically a serverless compute service, meaning the developers don't have to worry about which AWS resource to launch or how they will manage them. All they have to do is just put the code on Lambda and it executes. The AWS Lambda executes your backend code by automatically managing the AWS resources. When we say manage, it includes launching or terminating instances, health checkups, auto-scaling, updating or patching new updates, etc. So in order to create a REST API using AWS Lambda, the first thing that you have to do is create a Lambda function. Now to do that, you will have to open up the AWS console. Now if you already have an AWS account, just log into your account. Else, create a new account before you get started. Please note that AWS will provide free services for an year, and to know more about the free tier services, you can check out Amazon's official page for the same. Now since I already have an account, what I'm going to do is just log into my account and get started. Okay, so once you've logged into your account, you'll be able to see the AWS Management Console, which is just as you can see on the screen. Now, as you can see, there is a huge list of services that are provided by AWS. So if you just scroll down, you will notice that the Lambda service is present under the Compute section. So just click on that to move on to the Functions List page. This page basically shows all the functions that you have created in the current AWS region. Please make a note that recently created functions might not immediately appear it might take a while for them to show up. Now, as you can see, this page has several options such as create function, filter, actions, etc. Also, if you are a returning user who has already created some Lambda functions, you will see a list of functions that you have created, else the list will be empty. Now, if you want to create a new Lambda function, simply click on the create function option that is present at the top right corner of the page. Please make a note that the action drop-down list is not clickable. This is because the actions are to be performed on Lambda functions that are already created. So if you do not have any function, you will not be able to click on the actions list. However, if you have some function present already, select the function and you will see that the actions list gets enabled and it provides three options, that is view details, test and delete. As the name suggests, these actions will help you view the Lambda function details, test it or delete the functions if it is no longer required. Now, since we are focusing on creating a Lambda function, let me just create on the create function option. So now we've moved on to the create function page. The first option is author from scratch that allows you to create the Lambda function completely on your own. So if you want to create your own Lambda function, just give a suitable name and specify the runtime that you prefer. In our case, the name of the function will be Hello World. The runtime or the language that I want to make use of is Python. So I'll just select Python 3.8. So next up, after the runtime, you see something called as permissions, which basically refers to the function permissions. By default, Lambda will create an execution rule with permissions to upload logs to the Amazon CloudWatch logs. Amazon CloudWatch is nothing but a monitoring and management service. It provides data and actionable insights for AWS, hybrid and on-premises applications, and infrastructure resources. When you make use of AWS CloudWatch, you can collect and access all your performance and operational data in form of logs and metrics from a single platform. However, the default role can be customized later when you wish to add triggers. Okay, so now I'll go ahead and click on Create Function option. It will take a few minutes to do so, so let me just wait for the same. Okay, so once the function has been created, you will see the message just as you see on the screen, which says successfully created the function Hello World, which is the name of the function that I just created. Now this page basically allows the user to manage the code and the configurations. Once you have provided the required code and its configurations, simply click on test in order to execute the code. Now before doing that, let me walk you through this page. The first element that you see over here is page configuration. This element has something called as the designer. Here, you can add triggers, layers, and destinations to the Lambda function that you have created. A trigger over here refers to an AWS service or a resource that is used to invoke the Lambda function. Now, if you want to connect your function to a trigger, just click on Add Trigger option. And as you can see, there is a drop-down list over here with a huge list of triggers that you can choose from. Choose any service from the list to see the available options. As of now, I will not be using any of these, so I'll just click on Cancel to get back to the previous page. The next thing that you see over here is two options, that is the function that you've just created, which in my case is Hello World, and below that is Layers. By default, the function is selected, and when you scroll down the page, you will be able to see the code editor and a sample code that has been generated automatically for our function. Now, this is a very simple function called as the Lambda handler, which simply returns a message saying Hello World from Lambda. The code editor in AWS Lambda console enables you to write, test, and view the execution results of your Lambda function code. Okay, so now let me just scroll back up and select the Layers option. Layers are basically resources that contain libraries, a custom runtime, or other such dependencies. You can create layers to separate your function code from its dependencies. By default, no layer has been added. To add a layer, all you have to do is choose Layers and then click on the option Add a Layer. To include libraries in a layer, place them in a directory structure that corresponds to your programming language. Now, since we have a very simple function, I will not need any extra layer for it. But just for the sake of showing you guys, let me click on Add a Layer option. As you can see, there's a drop-down list present over here as well. There are two more options that are present over here. One is custom layer and the other one is specify an ARN. In the custom layer option, you will see any of the previously used or created layers. Since I've not used any, my list is blank. The next option that I see over here is to use an ARN. ARN basically stands for Amazon Resource Name. Entering an ARN enables you to use the layer that is shared by another account or a layer that does not match your function's runtime. The format in which you should specify an ARN is shown in the text bar itself. Okay, so now let's get back to the previous page. So I'll just click on Cancel. Next up is the Destinations option. Destinations are AWS resources that receive a record of an invocation after success or failure. You can configure Lambda to send invocation records when your function is invoked asynchronously or if your function processes records from a stream. To add a destination, choose Add Destination option. The contents of the invocation record and supported destination services vary by the source. Now the next element that is present over here is permissions. Like I've already mentioned before, the default execution role that we used for this Hello World Lambda function has permission to store logs in Amazon CloudWatch logs. Now this is the only permission it has got for now. The resource permissions can vary depending on the role that you select for the function. Finally, the monitoring element of this page. When you click on this page, you see some graphs which are not showing any data for now. This is because I have not invoked my function as of yet. Once the function is invoked, you will be able to monitor, trace, and debug your Lambda functions. Okay, so coming back towards the Hello World function, let me just scroll down to the code editor. So now, to invoke this function, I will have to test it. Before clicking on test, let me just show you the default test event that is present. Now you can open the test configuration either by clicking on Select a Test Event dialog box or opening the drop-down list that is present next to the test option in the code editor. So let's click on Configure Test Events. Okay, so now as you can see, there are some default test events that are present over here. Also, by default, the Create New Test Event option has been selected. The other option is Edit Save Test Events that cannot be selected as I have not created any test event before. So what I'm going to do is just give some name for this event, say Event 1, and then I will click on Create. Okay, so now our function is ready. To invoke the Lambda function, click on Test. As you can see, the message says execution result has succeeded. When you open the details, you will be able to see the summary of the log output. The summary section shows the key information such as the time taken for the execution, build duration, which is 100 milliseconds, request ID, etc., reported in the log output. The log output section will show the logs generated by the Lambda function execution. When you check the monitoring page this time, you can see that the metrics over here have updated. In order to gather some more metrics, all you have to do is just execute or run the Lambda function a few times. Okay, so now our Lambda function is ready. The next thing that we have to do over here is create the API gateway. So in step 2, you have to get back to the AWS console and from Networking and Content Delivery Service list, select API Gateway. Now in case you have already created APIs earlier, you'll be able to see them just like how you were able to see the Lambda functions list. Now, if you want to create a new API, click on Create API option. If you are using the API Gateway list for the first time, you see a page that introduces you to the features of the API Gateway. Now, since we are constructing on building a REST API, I will click on Build from REST API option. When you do this, you'll be able to see the Create New API page. Under Settings, for API name, you can enter any name and I'll be entering New API. Next, if you wish, you can enter a description in the description field. However, this is optional, so you can leave it empty as well. In my case, I'll just leave it empty. For the endpoint type, I'll keep it regional. Now once that is done, click on Create API. Okay, so as you can see, under resources, there is nothing but just a slash. This basically depicts the root level resource, which corresponds to the base path URL for your API. Next, click on the Actions menu. From the Actions menu, click on Create Method. When you do this, you will see that a new drop-down menu pops up below the root directory. This list basically consists of basic API methods such as get, put, post, delete, etc. For the purpose of this tutorial, I will select the get method and click on the tick mark beside it in order to save the choice that I just made. So as you can see, the get method setup pane has opened, and by default, the Lambda function option has been selected. If you remember, prior to creating this API, we created the Lambda function that we wish to use along with this API. So next, select the Use Lambda Proxy Integration option. For Lambda region, choose the region that you created the Lambda function in. In my case, it's Ohio. Now since Ohio is in US East 2, I'll just keep the region as US East 2. Please select the region according to where you have created your Lambda function. In the Lambda function field, enter the name of the Lambda function that you created earlier. Okay, so as you can see, the moment I type H, the function hello world is displayed in the drop-down menu. In case you forget the name of the function that you have created, just type any character and delete it. Then you will be able to see a drop-down menu that shows the Lambda function that you have created earlier. Leave the used default timeout checked, and finally click on the Save button to save your choice. Okay, so as you can see, a pop-up named Add Permission to Lambda function has been displayed that says, you are about to give API Gateway permission to invoke your Lambda function. Now this is exactly what we want. So just click on OK. So next up, you will see another pane that is Get Method Execution pane. As you can see, this execution pane consists of a number of items. The client box over here represents the client, which is the browser or the application that calls your API's get method. If you click on the test link and then click on test, this simulates a get request from a client. The method request box represents the client's get request as it's received by API Gateway. If you choose method request, you'll see settings for things like authorization and modifying the method request before it's passed through to the backend as an integration request. Now for this demonstration, I leave everything set to the default values. The next box that you see is the integration request box. This box represents the get request as it's passed to the backend. Here, the settings depends on the integration types that's selected. The URL path parameters, URL query settings parameters, HTTP headers, and mapping template settings are for modifying the method request as needed by the specific backend. The integration type for this demonstration will be set to Lambda function, and I leave the other settings set to the default values itself. So the next box represents the backend Lambda function that you have just created. If you click on this, it opens the Lambda function in the Lambda console. Integration response. The integration response box represents the response from the backend before it's passed to the client as a method response. For Lambda proxy integration, this entire box is grayed out because a proxy integration returns the Lambda function's output as it is. For a Lambda non-proxy integration, you can configure the integration response to transform the Lambda function's output into a form that's appropriate for the client's application. We'll be doing it later on in the other demonstrations, but for now, I'll just leave everything set to the default values as I've mentioned earlier. Method response. The method response box represents the method response that's returned to the client as an HTTP status code, an optional response header, and an optional response body. By default, the response body that's returned to your Lambda function is passed through as it is as a JSON document. So the response body default setting is application/JSON with an empty model indicating that the body is passed through as it is. For this as well, I'll just leave it set to the default values. Okay, so next is step 3. In step 3, you will have to deploy your REST API in the API Gateway console. Now until here, you've created your API, but you cannot actually use it. This is because it needs to be deployed. To deploy this, all you have to do is click on the Actions drop-down menu and choose Deploy API. From the Deployment Stage drop-down menu, click on New Stage, and for stage name, just enter prod. Once that is done, click on Deploy. So as you can see in the prod stage editor, the invoke URL is present right at the top. If you choose to invoke the URL, it will open a new browser tab with that URL. Now when you refresh this, you will see the default message that is hello from Lambda. Now if you wish to test the API that you've just created, you can make use of various tools such as curl or postman. In this tutorial, I'll be using curl. Therefore, I'll show you guys a quick demonstration of how to install curl for Windows operating system. So what I'm going to do over here is just open the browser and search curl for Windows. Select the option curl for Windows, and then you will see two options, that is 64-bit and 32-bit. Select the appropriate option that suits your system and download the same. Once it has been downloaded, extract the files. So the next thing that you have to do is open the bin directory of this folder, paste its path in the path variable, which is present in your system environment variables. So just open your system environment variables, select path, and click on new. Paste the path that you've just copied, followed by a slash, and then click on OK. Now, to test the API, open the command prompt and type the following command along with the link of the API that you've just created. So curl -x get in caps followed by the link. As you can see, I have the desired output displayed on the screen which says hello from Lambda. So the next part of our demonstration deals with creating another Lambda function. What I'm going to do over here is add a parameter to the Lambda function. So click on the service drop-down list and select Lambda. Just as before, click on create function, and I'll just name my new Lambda function as hello world2, and the runtime will be Python 3.7. Under permissions, expand choose or create an execution role, and from execution role drop-down list, choose use an existing role. From existing role, choose the role from your previous Lambda function. Also, you can create a new role with basic Lambda permissions. Then choose create function. In the function code pane, you'll see the default hello from Lambda function. Now what I'm going to do is just replace the entire function with the code that I've already kept ready over here. So I'll click on deploy. And the next thing that I'm going to do over here is add a resource, method, and parameter to the REST API in the API Gateway console. So I'll just click on Services, and then I'll click on API Gateway. From the APIs list, choose New API, and under Resources, click on /. Next, click on the Actions drop-down menu and click on Create Resource. For resource name, I'll just enter my resource. So notice that the resource path field is populated automatically with the resource name. Choose Create Resource. Next, from the Actions drop-down menu, choose Create Method, and under the resource name, that is my resource, you will see a drop-down menu. Choose Get, and then I'll just click on the checkmark icon to save the choice. Now in the My Resource Get Setup pane, for integration type, I'll just keep it as Lambda function. And for Lambda region, just like before, we'll choose the same region where we've created the Lambda function. In my case, it's US East 2. In the Lambda function box, type any character and then choose the Lambda function that you've just created, which is Hello World 2 in my case from the drop-down menu. Now, in case the drop-down menu doesn't appear, just like I've told you earlier in the first session, type any character and just delete it. So once you've selected the Lambda function that you created, click on Save. So once this is done, you will see the Add Permission to Lambda function pop up. Now this basically says that you're going to give API Gateway permission to invoke your Lambda function. Now since this is what we want, I'll just click on OK. In order to grant the API Gateway the permission that is required. Now once that is done, you will see the My Resource Get Method execution pane. Unlike the previous session, this time the integration response box is not grayed out. So just click on Integration Request and then expand the Mapping Templates option. Okay, so next, set the Request Body Pass-Through option to when there are no templates defined. So I'll just do that. And then I'll choose Add Mapping Template. For the content type, what I'm going to do is just type application/JSON and choose the checkmark icon. and then I'll click on the checkmark icon. Now in our case, the content type is application/JSON. Now in the template window, I'll just enter the code that I've already kept ready. Now this is the JSON document that will be passed to your Lambda function in the body of the input event object. The right-hand side of this tells the API gateway what to look for in your input query string. The left-hand side stores it into the parameter that you're about to add to your Lambda function. So once that is done, just click on Save. And from the Actions drop-down menu, I'll choose Deploy API. From the Deployment Stage drop-down menu, click on Prod and then choose Deploy. So as you can see, again, I have the invoke URL present over here. The next thing that I'm going to do is test the API that I've just created. So what I'm going to do is just open the command prompt and I'll enter the curl command, that is curl-x get followed by the invoke URL. Okay, so as you can see, I have the desired output, that is hello from Lambda. In the next part of our demonstration, I'll be showing you guys how to create an API gateway directly through the Lambda service. So get back to the Lambda console and select the Lambda function that you've created. As you can see over here, it shows that a trigger that is an API gateway has already been added. Now click on Add Trigger. From the drop-down list, select API Gateway. So I'll just click on API Gateway and then select the Create New API option from the API drop-down list. And for the API type, I will just select HTTP API. Now the security can be kept open since this is just for demonstration purposes. Please make note that for real-time applications, you cannot keep the security option as open. Then click on Add. Now when I come back to the Lambda function configuration page, you will see that there are two API gateways for this function. When you scroll down, you will see both the APIs that have been created. Open the details of the Hello World API and click on API endpoint link. Okay, so as you can see, the function returns hello from Lambda. Now I'll just click on test a few times and then I'll open the monitoring page to see the metrics. So as you can see over here, I have the corresponding metrics for my Lambda function through the API that I've just created. So till now, we have seen how to create a REST API using the Lambda function through various methods. The next thing that I'm going to show you over here is how to create a REST API with mock integration. A mock integration basically enables your API to return a response for a request directly without sending the request to a backend. This enables you to develop your API independently from your backend. So the first thing that you have to do over here is create the API. Now for the purpose of this demonstration, I will create an API with the get method and a query parameter in the API Gateway console. What I'm going to do over here is get back to the API Gateway pageant, and then I'll click on Create API just like we've done earlier. On the next page, what I'm going to do is click on Build for REST API. So under Create New API, choose API, and for the settings, I'll keep the API name as My API, and just like before, the description is optional, so I'll just leave it blank. Okay, for the endpoint type, set it to regional. The next thing to do is click on Create API. Now as you can see, the methods page option is empty, just like it was earlier. So from the Actions drop-down menu, click on Create Method. Under the resource name, that is /, you will see a drop-down menu. So from this drop-down menu, I'll just click on Get, and then I'll just click on the checkmark icon to save the choice. So now, as you can see, the Get Setup pane has appeared. Over here, for the integration type, I'll choose Mock, and then I'll just click on Save. Now we move on to the Get Method execution pane. Okay, so now we've moved on to the Get Method execution pane. Now the terms that are present over here have already been explained in the previous session. So in case you guys want to know what they are, just get back to the previous session and take a look at it. So for the next thing, what I'm going to do is create the mock integration. In this step, instead of integrating with the backend, I'm going to add a query string parameter to the get method, and then I'll specify the response codes and messages that our API will have to return. So first, create the query string parameter. Now for this, I'll just choose method request. In the get method request pane, I will expand URL query string parameters, and then I'll choose add query string. Over here, I'll just type my string for the name. I'll click on the checkmark icon. Okay. So next, what I'm going to do is create a mapping template that maps the query string parameter values to the HTTP status code values that are to be returned to the client. So I'll just get back to the method execution pane, and then I'll select on integration request. Okay, so from the integration request, I'll expand the mapping templates pane, and for request body pass-through, I'll choose the recommended option, that is when there are no templates defined. Content type again will be application/JSON. So I'm going to replace the contents that are present over here with the code that I've already kept ready. So I'll just paste it, and then I'll just click on save. So step 3 is to define the successful response. So what I'm going to do over here is create a mapping template that maps the HTTP 200 status code value to a success message that is to be returned to the client. So I'll just click on method execution, and from here, I'll move on to the integration response. Now expand the 200 response, and then expand the mapping template section. Okay, so under content type, I'll just choose application/JSON. And for the template contents, I'll just have a basic message that says hello from Edureka. Okay, so I'll just paste that over here, and then I'll click on save, that is present in the mapping template section. Please make a note over here, guys, that you can see two save options. One is in the mapping template section. From both these options, you will have to select the save option that is present in the mapping template section. Now in step 4, I will add an HTTP 500 status code and an error message. Okay, so in this step, what I'm going to do is add an HTTP 500 status code that the front end can return to the client, and then you map it to an error message. So first, I'll have to add the 500 status code. So I'll just get back to method execution, and I'll click on method response. Then just click on add response. For HTTP status, enter 500, and then click on the check mark, and then I'll just click on the check mark icon. Okay, so now create a mapping template that maps the returned 500 status code value to an error message from the front end to the client. So for that, I'll just get back to the method execution pane, and I'll get into integration response. Then I'll choose add integration response, and for HTTP status regular expression, enter 5/d and 2 within curly braces. Now for method response status, choose 500 from the drop-down menu, and then just click on save. Next up, all you have to do is expand the 500 response, and then expand the mapping template section if it isn't already expanded. Under content type, I'll choose add mapping template, and in the box under that, I'll just enter application/JSON, and then I'll click on the check mark icon. Now the message over here will be replaced saying that this is an error message. Okay, so I'll just paste that, and I'll save the changes. Now for the final step, that is step 5, I'll have to test the mock integration. So I'll just click on method execution, and I'll just click on the test option that you see over here. Now under query string, I'll just enter my string equals my value. And then I'll choose test. So as you can see over here, we have our desired output that says hello from Edureka. Now this basically means that we have successfully created the mock API. Now in case you want to check if the error condition is also working, all you have to do is just go back to the query string text box and just delete some item from there. What I'm going to do is just delete whatever value is present for my string, and I'll just leave it as an empty string. Okay, and then I'll click on test. So there it is. You can see the desired message that says this is an error message. So this brings us to the end of this AWS API Gateway. So I hope you guys have enjoyed and learned something new. In case you have any doubts or queries, please do let me know in the comment section, and I will revert to you at the earliest. We'll be back with more and more exciting sessions, but till then, goodbye and take care.